We're going to look at the solution to case H. If you have not looked at this problem previously and attempted to answer it on your own, then stop here and look at the problem carefully and try and solve it on your own without my help, and then come back and view this video afterwards. Okay, going forward, assuming that you've tried this on your own, this problem is relatively straightforward. What's important is that it's an example of a past exam problem. I don't think it's useful for students to have the expectation that future exam problems will be very similar to past exam problems. That's not true, but conceptual problems are all equally likely, or all these problems perhaps are equally likely to show up on the exam. It does help you actually to see an example of what I might ask on an exam. So we're going to take a look at this problem, and I find it useful to look at this problem using a Venn diagram. This is a fairly classic example where we just have two intersecting events. It's just a matter of how much do they overlap. Now there's two ways that this firm can win an award. One award is an award for design, and the other award might be for materials. Turns out materials is more likely to get an award. The total probability of falling in that circle for the materials, that's total in both the intersection portion and outside, is equal to 0.25, and the probability of being in the circle for design only is equal to 0.16, and probability of an award for materials use is 0.25. How much is in an intersection? Well, what we are told is that the probability that you'll get both awards, that the firm will get both awards, the probability of design and material awards, is equal to 0.11. With that, we actually can proceed and get all of these, because we know that the probability of being in the circle M total is 0.25. So what's the probability of being outside of the intersection but inside M? That's 0.25 minus 0.11, or 0.14. And what's the probability of being in the design award circle but outside the intersection? It's 0.16 minus 0.11, and that's just 0.05. So we now have our probabilities for each of the areas, and I think we should be able to proceed. So question A asks, what is the probability that we'll get at least one of the two awards? That's the probability of design or materials award. That's going to be equal to, you can just add up those three parts, 0.05 plus 0.11 plus 0.14, or you could just, and we just add those up, and I get 0.16 plus 0.14, 0.3. You could also have calculated that as the probability using the classic definition, probability of, oops, I have to rewrite that. The probability of design award plus the probability of the materials award minus the probability of the intersection, because we don't want to double count that, and that's equal to 0.16 plus 0.25 minus 0.11. So you could have gotten to 0.3 either of those two ways. Then B, what is the probability that we'll get only one of the two awards? So just one award, probability of just one award. So we can get that by recognizing that we want the parts of being inside just one circle but not inside both. So that's that portion plus this portion. 0.05, that's our chance of being just inside the D, and our chance of being only inside the M is 0.14, so those total to 0.19. And in question C, it says, given the probability values in the statement, are the two awards statistically independent? Why or why not? So this is one of those concept questions. If independent, then we would expect the probability of the design award and the materials award would be equal to 0.16 times 0.25, which gives us 0.04. But the probability of both the design and materials award was found to be 0.11, so not statistically independent. Not statistically independent, because if it was statistically independent, the probability of the overlap could be calculated by multiplying the two probabilities together, but that's not the case. We actually have a very different probability, so they are linked. And you shouldn't be surprised, because when the team does well and puts together a good design, it isn't surprising that it becomes increasingly likely that they have a greater chance of winning both awards. So that's the end of this problem. We're done with case H.